Good morning. If you're just joining us, we will be starting in just a couple of minutes. We're waiting for people to join our June Dig Deeper. Thank you for attending this morning. If you're just joining us for the June Dig Deeper, we will be starting shortly. Thank you for attending. Morning. If you're just joining us for the June Dig Deeper, we will be starting in about 1 minute. All right, good morning. I'm Jeff Hammond, Executive Director at International Ground Source Heat Pump Association. Thank you so much for joining us for the June Dig Deeper. This Dig Deeper is sponsored by Centennial Plastics. Centennial was one of our gold sponsors at last year's annual conference. And one of the benefits of that gold sponsorship was being able to sponsor an IGSPA Dig Deeper webinar. So we appreciate Centennial and their commitment to the industry. It's appropriate this morning that we're talking about Centennial Plastics because we have a presentation on piping. So before we turn this over to our speaker, Lance MacNevin, I'll go through just a few updates to bring everyone the latest IGSPA news, and then we'll have our presentation for the morning. Just a reminder, if you'd like to speak at a town hall or a Dig Deeper, go to igspa.org. We do still have a few slots open for 2024. There's a button on the homepage called Training and Events Calendar. You'll find an abstract on that page if you'll submit that, and then we'll consider your presentation for one of these webinars. Happy to announce that we are well underway for the next annual conference. We're pushing it back just a few months so that it's not in December. It's actually going to be a spring conference. So it's March 11th through the 13th in Champaign, Illinois. And we're working with Geothermal Alliance of Illinois on this conference. You'll find a lot of details at igspa.org. And you'll notice that this hotel block is already filling up quickly, almost half full. So if you want to just walk from your hotel room over to the conference center, you'll want to try to book your hotel reservations as soon as possible. Now, if that hotel room is full, or excuse me, hotel block is full, there are other hotels in the area, but the advantage of the conference hotel is that it's right on the conference property. Also, we're accepting abstracts for workshops. If you'd like to speak at the conference, please submit an abstract on this same location at igspa.org. We have early bird registration through January 31st, and the prices do go up at that point. And you'll also find information on sponsorships for the conference, exhibitor opportunities, including now an outside space for large equipment. And conference advertising will be available here soon, probably in the next month or so. You can see here we already have a number of sponsors for the conference. Thank you so much to our conference sponsors. We certainly could not provide a great conference without these sponsors. There are still some spots available. You'll see this online as well, and details and pricing are there. The exhibit hall is starting to fill up. We have a couple of 20 by 20 booths left, and we have a number of 10 by 10 and 10 by 20 left. There's also, as I mentioned earlier, an outside space for heavy equipment, which includes a table in the lobby. So we're going to see a lot of really good exhibitors this year, as well as presentations, I'm sure of it. Our Geo Outlook magazine is slated to come out the end of July, and we're already accepting articles and advertising for the next edition, which will be January. Right now, we're at 2 per year. We're hoping to go to quarterly in 2025. And that's, of course, contingent on the availability of articles and advertising. But at least to start off, it's 2 per year, January and July, and then we're looking at quarterly moving forward. It is a great opportunity for article writers as well as advertisers because of the reach of this publication. Not only do we have the IGSPA database, but because we're partnering with BNP Media, you should be familiar with their publications, Engineered Systems, ACHR News, and many more. Our reach now is about 50,000 readers, so it's a good opportunity to work with GeoOutlook. If you're not getting the GeoOutlook magazine, make sure you shoot us an email. You might have accidentally unsubscribed, or you may not be on our list of email for our campaigns. So let us know if you're not getting this magazine. We do have a new membership program that started at the beginning of the year. It's a lot of different levels now. Check that out. Having IGSPA membership has many advantages, and we continue to have more as time goes. In fact, one of the big advantages is a brand new member portal that started in April. A lot more detail now on the member portal, as well as resources, marketing resources, trainer resources, and so forth. We have 2 new databases online, another IGSPA membership benefit. One of them is our geothermal project database. We've started with quite a few links, but we definitely need your help. If you have projects in your area, please let us know. We'll add those to that database. And this is phase 1, so it's a page with links, actually multiple pages. Phase 2 will be a searchable online database, and phase 3 we're going to be adding more details. The other database is licensing and CEU requirements. So the goal of these databases is to help members learn about what's in your local area, but also what's required to get in the industry. So we're trying to help as much as we can expand availability of services and products. You probably saw the e-news and also the posting on the IGSPA website that the ANSI CSA IGSPA C448 standard is now out for public review through August the 6th. A couple links here on the page. You can go to publicreview.csa.ca to actually do the public review. Or if you'd like to read about it a little bit more, go to IGSPA.org/news, and it has this link as well as all the changes to the next edition. Once this next edition is published, we will be sunsetting our 2017 IGSPA standards. And so this binational Canada-US standard will be our reference for IGSPA materials, for training, and hopefully add more consistency to the industry. If you'd like CEUs for this webinar, just send us a chat, or if you can't access chat, use the Q&A, and we'll need your name and email address in that message, please. Also, if you happen to be watching this webinar as a recorded session, you can still get the CEUs. Just simply send us a note with this webinar code, and you'll be eligible for receiving those CEUs even as a recording. If you're watching live, you don't need this. This is only for people who are watching the recording. Just a couple of housekeeping here. If you would type your question in chat or Q&A, and I will read those questions at the end of Lance's presentation. We'll try to get to all the questions if possible. And at that point, then we should follow up, or we will be able to follow up if we don't get to all of those. It will be recorded, so you can view it later on if you don't have the opportunity to see this one or get your questions answered. You can review it later on. A little bit more housekeeping. We have had some people that are having difficulty in getting to the chat feature. So we've turned on Q&A as another option. Also, you might get a message like this one over here on the right. And if you do, you might have to click OK in order to enable that chat feature. If you can't use Q&A or you can't use chat, raise your hand and we'll unmute your microphone. You'll be able to ask that live. All right, one more slide and then we'll be ready for our presentation. Just a quick disclaimer and potential conflict of interest. The upcoming presentation represents the opinion of the presenter and does not represent any official position, opinion, or endorsement of any products or services by IGSPA or its members. IGSPA town halls and Dig Deeper webinars are for member updates and education on the latest information in the geothermal heat pump industry and are not meant to endorse one technology or brand over another. It is a presenter's responsibility to disclose any conflict of interest, or position that may arise in the content of the webinar. With that, I'm thrilled to introduce Lance MacNevin from PPI. Feel free to share your screen whenever you're ready, Lance. Lance is the Director of Engineering for the Building and Construction Division at Plastics Pipe Institute, or PPI. He has been in the plastic pipe industry since 1993, involved with applications such as hydronic heating and cooling, geothermal, plumbing, and fire protection systems. Lance earned his IGSPA accreditation in 2008 and has been closely involved with the geothermal industry ever since. With a focus on the piping materials used for ground loops, he serves on technical committees within ASHRAE, ASPE, ASTM, AWWA, CSA, IAPMO, ICC, IGSPA, and RPA, with a focus on code standards and training. He is chair of the piping task force for the next edition of ANSI CSA IGSPA C448. Thanks so much, Lance. It's off to you.
Well, good morning, Jeff, and good morning, everybody. Thank you for having me. Just having one little difficulty, and you would think we do this all the time, but I've never run into this issue where it won't go into presentation mode. It did before on our trial. Now, let's try a different format here for getting this into presentation mode. And hold on one second. I'm going to stop sharing for 1 second and close the file and then reopen it. And we'll get this open again.
Sounds good. We do so many of these, but occasionally we get a little bug that drives us crazy.
Yep. And every platform is different. How is that now?
I think that's present. That's your speaker. But you may have to swap displays. Perfect.
Okay. All right. There we go.
Thank you, Lance.
All right. Sorry about that, everybody. But again, glad you're here and good morning. So yeah, the presentation I'm going to do today is called the New Model Specification for Geothermal Piping Materials. And we're all very familiar with plastic pipes used in geothermal systems. And you probably look at these pipes and touch them and install them all the time and think to yourself, well, it's a black round pipe. How complicated can this be? How many words does it take to specify black round pipe correctly? Well, it can actually be pretty complicated. And there's a lot of science and detail in pipes, and there's a lot of ways of specifying the pipes correctly. If you don't do it correctly, there is a chance that you get incorrect pipes put in the ground, which can obviously be very, very costly, almost impossible to replace them sometimes, and could lead to premature failure if you don't have the right pipe in the ground. So that's kind of the background for this. As Jeff mentioned, here's my specifications. And I work for the Plastics Pipe Industry, which is a nonprofit trade association based in Irving, Texas. PPI has been around since 1950, before all of us were born. And our mission is to advance the acceptance and use of plastic pipe systems through research, education, technical expertise, and advocacy. So as a bit of an introduction, what we're going to be talking about today is a new PPI document that published a year ago called Model Specification for Plastic Piping Materials for Ground Source Geothermal Applications. So hopefully the title is pretty self-explanatory. The official number of the document is called PPI MS7 for Model Spec 7. That means we published 6 other of these beforehand. But this one is focused on the pipes that we're using in the ground for geothermal systems. So we're going to talk about why it's important to have a model specification and to use correct language, and then walk you through the document and show you how to actually use it correctly. But first, on our presentation outline here, we're going to start by focusing a little bit on the science and specifications of HDPE pipe tubing and fittings. And we're going to first take a look at what the code requirements are for HDPE pipe tubing and fittings, and then delve into the standards requirements from organizations like ASTM, AWWA, CSA, and NSF, so that we understand how standards and codes and standard language work well together. And then the fun part of this is going to be taking a look at some inappropriate or out-of-date piping specifications. These are real specifications used on projects in the last few years that if you follow those literally, there might be no product that meets those requirements, or it may be very confusing in terms of which product to supply. So we'll take a look at those and point out kind of what's wrong with them. And then we'll finally, in item 4, we'll actually share the new PPI document and give you a tour of what's in there and how you can utilize it going forward, especially if you're a specifier or an engineer. But many of you are probably working with specifiers and engineers as well, and could kind of share this information with them to make their life easier and your life easier too. So that's the plan. We got these kind of 4 items in the presentation. So the first of these is we're going to be taking a look at the actual codes and standards, starting with the codes. And you've probably all heard other presentations by different presenters describing what is a code, right? So this may be a little bit repetitive to some of us. But our definition that we're giving here today is that a code is a legally adopted document by jurisdiction for the purpose of regulating a portion of the design and construction industry. So we have plumbing codes and fire codes, construction codes, mechanical codes, and then geothermal codes as well in some cases. Most jurisdictions, whether that's my city, my town, or my state, they don't have the capacity to develop their own codes, so they adopt model codes from big agencies like ICC or IAPMO or IGSPA or NRC up in Canada. Some jurisdictions do develop their own codes, and sometimes that doesn't turn out for the best. They could end up being really out of date or ill-informed. So we generally encourage any jurisdiction to adopt one of the big model codes as their codes. So the groups that write those so-called model codes are called code development bodies or simply code agencies. And again, International Code Council is ICC, or the International Association of Plumbing and Mechanical Officials, that's IAPMO, and National Resources, the Council of Canada, NRC, that adopts the construction codes for Canada. So when a code or a standard is adopted through the appropriate legislative process, then the standards and model codes become obviously the law of the land for the jurisdictions. And in some cases, something that's developed first as a standard, like CSA C448, can actually become then adopted as a code when a jurisdiction, like a state or a county, says, we're going to use C448 as the geothermal code for this territory. So that's just kind of an intro to codes. In terms of what codes are out there for geothermal systems, there's primarily 4 of them in North America right now. There's the ANSI CSA IGSPA C448, which Jeff was talking about, and Jeff is the chair of that committee within CSA, and we're looking forward to the new version being published soon. And in the United States, we have the International Mechanical Code from ICC, and then IAPMO has 2 different codes that include geothermal content. There's the Uniform Mechanical Code and the Uniform Solar Hydronic and Geothermal Code that has a specific chapter just on geothermal systems. So we're going to take a look at each of these in detail. For C448, it's the 2016 edition, it's still the current edition that was reaffirmed in 2021. And for the other codes, we're going to take a look at the 2021 edition of those in detail and just see how those codes refer to piping requirements. And this is kind of setting the stage for how model specification should be arranged and written. So if we go into C448, the current edition, and go to the section 542 on polyethylene pipe and fittings, we'll see that the very first line says PE pipe and tubing shall comply with CSA B137.1 or ASTM D2737 or D3035 or these other 2 standards. The code is actually referring to a standard. The code doesn't actually say exactly the dimensions of the pipe or the strength of the pipe or the marking requirements of the pipe, because all of those kinds of details are actually written in product standards, which we'll talk about in a few minutes. So it's much easier for the codes to refer to a standard, select a standard for a pipe that is appropriate for the application, and say, as long as you use one of these standards for the pipes in this system, that will be appropriate, and that will meet the minimum requirements. So that's one example of code referring to a standard. If we look at the 2021 IMC, Chapter 12 in the IMC is on hydronic piping, and then geothermal is grouped into the hydronic chapter of the IMC. So table 1210.4, what we're showing in the screen here, is the table for approved ground source loop pipe, is the language they use in this code. And for high density polyethylene, we'll see the same standards that we saw in C448, We have ASTM standards, a CSA standards, and an NSF standard. And then also in that same code, if you go further down the page, you'll come to table 1210.5, which is on ground source loop pipe fittings. So for HDPE, it also uses ASTM or CSA or NSF standards to talk about which fittings are approved for use with that polyethylene pipe that was in the previous table. So that's a way of kind of saying what parts you can use together. And one of the IATMO codes, this is the 2021 Uniform Mechanical Code. And in this version of the code, it was actually Appendix F that was on geothermal energy systems. And table F104.2 describes the approved ground source loop piping. So very similar table to the others that we looked at. For HDPE pipe, here are the standards that the pipe must comply with. And the pipe doesn't have to comply with all of them. And in fact, it can't. But the pipe has to comply with at least one of these. And then the next table, there's a table for ground source loop pipe fittings, again, referring to different fitting standards in there. And then we have the other IATMO code called the Uniform Solar Hydronics and Geothermal Code, the USHGC, and it has a table 703.2 for ground source loop piping. And again, it's referring to those standards for the approved pipes. And then it has another table for the fittings. So I'm not showing that for because it's kind of duplicative. But the main point of this first point of the presentation is that the model codes are very specific about the approved products and procedures that you're allowed to use. And the codes approve product by reference to the accredited product standards. Now, these codes get updated. They're not locked in stone. And in fact, most of the US codes get updated every 3 years. And I was showing examples of the 2021 codes, but the 2024 codes are actually out and available for sale now. And some jurisdictions are starting to adopt the 2024 codes already. And believe it or not, a lot of us in the background are also working on the development of the 2027 codes. So that work actually started last year for what's going to be in the 2027 codes. So it's a constant process. These codes are always in development and always subject to change. If you have a better idea for fixing something, there, is a process for updating the codes. So that was part one. Here's part two. Now we're going to dig into the product standards in a little more detail. And this is going to be hopefully a little bit educational in terms of some of the details of the standards and why it's important to reference the right standard when specifying your pipe or fittings. So the first question we often get is, well, where do these standards come from? Who writes them? So the standards are actually produced and published by organizations that we generally call standards development organizations, or SDOs. That's just kind of the title of that type of organization. Some examples of these SDOs for different types of products are AHRI, ASHRAE, AWWA for water systems, ASTM, CSA, IATMO and ICC also develop standards, and NSF develops a lot of pipe standards as well. So those are the organizations that develop relevant standards here for geothermal activities. And standards development organizations have to be accredited by somebody to say that they're doing the job correctly and that they're open and transparent and that they're not creating confusion in the marketplace. So in the United States, the accreditation body for that is called ANSI, the American National Standards Institute, ANSI. And in Canada, we have Standards Council Canada, SCC, that actually accredits standards development organizations to make sure they're developing useful standards in a correct manner. And also that two different organizations aren't developing completely identical standards that would compete with each other, because that can create confusion in the marketplace. So the purpose of a standard, I think this is pretty obvious, but it's defined as a set of technical definitions and requirements for product design, manufacturing, testing, and certification. So there's a lot of stuff gets captured in a product standard. And again, these are all minimum requirements. People can certainly make products that are better than the standards, and they usually do. But the purpose of the standard is really to protect consumers, to make sure that when they buy something like a pipe, they're getting a pipe that meets an agreed upon set of minimum requirements. And those minimum requirements are driven by various factors. They could be driven by an organization like IGBA that says we need pipe that's going to last and not collapse, and it can't dissolve in water, and it has to be resistant to antifreeze products. The standards requirements can be driven by the public, the people who buy the pipes that actually have their own expectations, and the standards can also be driven by the manufacturers who know what's capable of being produced. And the manufacturers are always actually trying to raise the bar as technology improves. These standards are literally being improved on a very regular basis to make them tighter and better and increase requirements as technology improves. So there's a lot of motivation to keep updating the standards. And that's another reason why it's important to always know what is the latest version of these standards, because they always get better. And that's also driven by competitive reasons too. So if we look at the list of the HDPE pipe and tubing standards that we saw in the codes a minute ago, you saw all these numbers like ASTM D2737. Well, you can look that up online. And if you want a copy of ASTM D2737, you can buy it. ASTM's main business is selling standards that are developed by its committees. So you could go online right now. Well, wait till my presentation is over. You can go online then and just purchase a copy if you want to see all the details of what's in D2737 or D3035 or F714 or AWWA standards or the other standards. They're all available to anybody with a credit card who wants to purchase them and own the standard. The same thing for the fittings and the joining practices and drinking water safety. There's standards for all of those items as well. So there's 3 different ASTM standards for different types of fittings. The first one shown here is for socket type polyethylene fittings. The second one shown here is for butt heat fusion polyethylene fittings. And then the third one is for electrofusion polyethylene fittings. So those are 3 individual standards for the 3 different types of fittings used with polyethylene pipes in these applications. And then there's also 2 ASTM standards for actually connecting these fittings correctly. So 1290 is the standard practice for electrofusion joining. So standard practice means here's how you use the product correctly, as opposed to a standard specification, which is here's how you make the product correctly. And then ASTM F2620 is the standard practice for heat fusion joining. And that means socket fusion and butt fusion. So if you're doing fusion joints, hopefully you have copies of these standards and you're following them, because these are the industry's minimum requirements for making good heat fusion or electrofusion joints. Now, the question often comes up then, well, who is actually writing these standards for plastic piping systems? Does ASTM include, thousands of engineers that know how to write all these standards? Well, yes, they do, but they're not employees of ASTM or AWWA or CSA. The people that write the standards are actually technical committees of volunteers, people from industry or from the public that volunteer to join those organizations and to contribute and collaborate in actually writing these standards. And this has been going on. ASTM is now 126 years old. The first standard ever published by ASTM was for steel rails in railroad rails, standard A01. 51 years ago, ASTM formed a committee called F17, which was focused on writing plastic pipe standards. And that committee has about 750 people today. And that's the ASTM technical committee that writes standards like the ones we were talking about here today. And within ASTM, they have subcommittees that focus on different types of pipes, because the people that are experts in polyethylene pipe are probably not also experts in PVC pipe or drainage pipes or something else. So there's different committees for different types of pipes for different applications. So for example, in the box here, what I'm showing is the footer of ASTM D3035, which is a really common polyethylene pipe standard. And in the bottom of that standard, it actually tells you this specification is under the jurisdiction of Committee F17 and the subcommittee of F17.26. That's the name of the subcommittee that actually prepares this standard. And it tells you when the standard was originally approved. And in this case, it was originally approved in 1972. So D3035 has been around for a very long time. And then it also tells you about the latest edition. So that gives you a little bit of a detail in terms of where the standards come from, I hope. And then mostly they're black and white standards, except some of them have fancy color covers. But here is just kind of a list of the common standards that we have for HDPE piping systems. So sometimes people will refer to this AWWA standard called C901. That's the American Water Works Association. the ASTM standards that we normally use. And ASTM used to be known as the American Society for Testing and Materials, and now they just go by ASTM International, but that's where the acronym comes from. So they have the standards like D2737, which is for tubing. So D2737 is for PE tubing. D3035 that I've been talking about is for outside diameter controlled pipe. And then we have a CSA standard B137.1, which is also for polyethylene pressure pipe and tubing. And then there's the NSF standard 358-1, which is specifically for polyethylene pipe and tubing for geothermal heat pump systems. And then sometimes we're going to be talking about NSF 61, which is the standard that requires components to be safe for drinking water contact. Now, to take a closer look at one of these standards and get an appreciation of what's actually in there, I've got a few slides about D3035 in terms of what's in the guts of the standard. So here's kind of the cover page of D3035. This is a standard for OD controlled polyethylene pipe. And the scope tells you what it's for. If you look inside, if you look at table 2, for example, this is the for IPI size pipe, meaning iron pipe size pipe. This is the table for outside diameters and tolerances. So if you're wondering what is the outside diameter of any of these pipes, that's defined in the standard. And look at these tolerances. Like for IPS size 1, the outside diameter is 1.315 inches, but the tolerance is plus or minus 5 thousandths of an inch. A piece of paper, it's about 4 thousandths of an inch. A human hair, about 4 thousandths of an inch. So that's the tolerance that the manufacturers have to make pipes correctly to a standard like this. Very tight tolerances. There's a separate table in here on the minimum wall thickness. So you have all these different dimension ratios of plastic pipes available, DR11, DR9, DR17, and it's pretty small text on the screen here. It's hard to read, but the exact tolerances for the wall thickness is also specified in the standard. A lot of the material properties are specified in the standard. And on this section here, if you can read section 9 at the bottom, that's on markings. So the exact marking requirements are also specified in the standard. And again, these are all minimum requirements. People can put more in the markings if they want to, fancy logos and stuff like that. But at the very least, they have to put what's specified in the standard on their pipes. So there's a lot of requirements in here. Similarly, the NSF 358-1 standard, it exists to be a special standard for geothermal pipe because it also includes special requirements for compatibility with antifreeze products. So this is just the scope of NSF 358-1. And you'll find that most of the geothermal pipe on the market today will be certified to an ASTM standard and also certified to NSF 358-1. 358-1 have strength requirements, and for dimensions, it refers back to the ASTM or CSA pipe standards in the first place. For the fittings, NSF 358-1 talks about the fittings and how they have to meet specific standards, like we talked about earlier. And then it even has a special section on chemical resistance. So if you have a polyethylene pipe certified to NSF 358-1, that means that pipe has gone through the chemical resistance test with different types of antifreeze products to make sure that the pipe is resistant to those antifreeze products. So there's a lot of, and here are those antifreeze products here, ethanol, methanol, and propylene glycol. So there's a lot of really specific requirements in this standard as well. I'm not going to spend a lot of time on material properties today, simply in the interest of time. But if anybody would like a copy of these slides, I'm happy to distribute them to IGSHPA for sharing, or anybody can send me an email, and I'm happy to send these slides out to you because there's a couple of slides in here with details of exactly what is meant by a cell classification number on polyethylene pipe. And there's actually a table for this in a different ASTM standard that talks about exactly what is the density range and the melt index and the flexural modulus. So for polyethylene pipe materials, the material used to make that pipe, there's a lot of requirements even for the materials as well. And those requirements actually get spelled out in a number called the pipe cell classification. So in most polyethylene pipe, if you read the pipe print line, you'll probably see the number like PE 4710, but you'll also see a number like 445574C. And in the 445574, each of those digits refers to a property in the pipe. And those properties are listed in this table here. But the PE4710 part is typically what people talk about. And in the old days, we had 3408. And then for a while, we had a product called PE3608. And there's still a little bit of that still exists. So what do those numbers mean? Because those numbers aren't the same as a cell classification. These are 4-digit material designation codes, is what the designation like PE4710, that's called a material designation code. And it's defined in an ASTM standard called F412 that the first digit refers to the cell classification number for the density. So a bigger number means higher density, higher strength. The second digit refers to the cell classification number for slow crack growth resistance. And that means the resistance or the ability of the pipe to resist cracks even when you get a gouge or a scratch in the pipe. The old 3408 pipe, that was its biggest weakness. If you got a scratch or a gouge in the pipe under constant pressure and ground movement and things like this over time, those little cracks could turn into bigger cracks. But today's polyethylene pipe, like PE4710, it's literally 100 times or more better than the old pipe in terms of resisting crack growth. And the third and fourth digits of PE4710, that is a shortcut of 1000, and that refers to the hydrostatic design stress of the material. It doesn't mean that the pipe can withstand 1000 psi of internal pressure. It means that the pipe material, if you had a square inch of it, could withstand 1000 psi of stress on the pipe material itself. So imagine you had a burr of that polyethylene material, 1 inch by 1 inch. It could withstand 1000 pounds of tensile stress without elongating. So all of those numbers actually mean something, and it's really important to use them correctly so that you get the pipe that meets the requirements that's needed. So to wrap up this part of the presentation, hopefully you have a little bit of better appreciation of what's in a product standard now, and how important it is to actually specify the latest version of these product standards, because they really include a lot of detailed requirements. And in fact, I think anybody who reads a product standard will be thoroughly impressed by how high the requirements actually are for these pipes and fittings, and the materials and all the testing that's required. And the truth is, the companies that make plastic pipes and fittings have to spend tens of thousands of dollars every year on internal quality control, but on third-party certifications as well. In fact, a lot of companies are spending hundreds of thousands of dollars a year on quality control and annual certification testing to make sure that the pipe is meeting the standards. And you have to test things to failure, so sometimes tests take a really long time to get these pipes to fail. So now we're going to move into part 3, which is examples of inappropriate piping specifications. So we're going to look at some real specifications and then point out what's wrong with them, as a way of saying, well, here's how you could do it right, to avoid these problems. And the concern, and you've probably all seen this, that bad specifications, they could refer to inappropriate product standards. And then that causes confusion because the manufacturers, the people asked to supply the pipe, aren't sure which kind of pipe is really intended here for this project. So the wrong products might actually get supplied and installed. And in some cases, the product specification might refer to an old specification that is really inadequate compared to today's specification, when the bar is far too low. And maybe it's a product not even in production anymore, so everybody's just kind of guessing, what are they really looking for here? But in a lot of cases, what we see is engineers are kind of making up their own specifications with a little bit of this from one standard they read, and a little bit of this from another standard they read, and combining it in a way that they're trying to get the best of the best in one specification. And that's what Dr. Frankenstein tried to do in the story. Get the smartest brain and the biggest arms and the fastest legs put into one person, but it turned out to be a monster, right? And sometimes that happens when people are trying to do this by mixing and matching and building their own specifications. They come up with language for which no product can actually comply. Monster specifications. So here's some examples of some of these specifications that are real specifications, but they're just not right for specifying for geothermal pipes. So this is one here. And no names are going to be given. I don't know who wrote these. They were given to me anonymously, so hopefully it wasn't any of you. On this specification under geothermal ground loop piping, for the ASTM standards, it lists ASTM D2513. Well, that's a gas pipe standard. And gas pipe doesn't even have to be high density polyethylene. Gas pipes are really low pressure in a lot of cases, and they can use medium density polyethylene. So it's not appropriate to use a gas pipe standard for geothermal piping requirements. On this specification here, under the section in quality assurance, it says all components shall be supplied by one manufacturer. Well, the truth is the companies that make pipes don't make fittings, and the companies that make fittings don't make pipes, um, except in maybe some very rare cases around the world. For the most part, there's pipe companies and there's fitting companies, but they can't all be coming from one manufacturer because they don't own each other. And then letter D in this specification says pipes and fittings shall be IGSHPA approved. And as far as I know, IGSHPA does not have a product certification program to monitor pipe factories and go do audits and test and approve products. On this specification, there is a particular manufacturer listed. And then it says the ground loop heat exchange pipe shall be SDR11 PE4710. Well, that's fine. But then it says it shall be crosslink polyethylene pipe, PEX-A type. So it can't be PE4710 and PEX-A at the same time. That's like asking for apples and oranges to be mixed together. So that's just inappropriate. And the company Oil Creek Plastics doesn't even produce PEX. So we have no idea where this language came from. And then in the same specification, next page, it says the piping shall be SDR 13.5 PE4710. Well, that's okay, that exists. But then down below under letter C for the fittings, it talks about the PEX fittings, and that the electrofusion fittings shall be made from PEX, and those don't exist either. So it's really a mix of different things. This is a different example specification. So you can see it's a different format, different layout. And in section 0.2, it says the geothermal piping shall be manufactured from virgin HDPE resin. Well, it's okay to say that, but you don't actually have to say that because that's actually already a requirement in the standards that all the HDPE pressure pipe is made from virgin resin. You're not going to get any recycled product mixed in with your HDPE pressure pipe. So that kind of goes without saying. But with 0.7 and 8 down below, well, 0.7 especially, has a bit of a problem because it says the pipe shall have a nominal diameter of 32 millimeter or 1.25 inches. And from all those product standards that we looked at earlier, from AWWA and ASTM and CSA, none of them include a 32 millimeter pipe. Even CSA standards in Canada use the same nominal pipe dimensions like 1 and 2 and 4 and 6 that we use in the US and ASTM standards. So if you really want a 32 millimeter pipe, you're going to have to use an ISO standard and specify some isometric pipe coming from Europe or Asia. It just doesn't exist in North America. And then down below, the pressure rating is the KPA rating and the PSI rating don't actually match each other. So that's just a bit of a technical error there. On the same example, on the next page, it says all distribution header pipes shall be PE 4710. Well, that's fine. But again, then it calls out the metric dimensions. So the Europeans aren't using PE 4710 material, so it's going to be practically impossible to get a 50 millimeter PE 4710 pipe. And then down below at the bottom of the page, they're actually talking about the virgin resin with cell classifications that don't match PE 4710. Those cell classifications are really low grade polyethylene materials, lower spec than PE 4710. So you can't really do both at the same time. Here's another example, again, where they're calling out 32 millimeter pipe. Same problem there. They're also asking for virgin pipe material, which you get without asking. You don't have to ask for that. They're also asking for the low-grade cell classifications, which are much lower than PE 4710 material. So that wouldn't be a very good quality pipe if you asked for 345, 564. And then it's also asking for a certificate of origin of the pipe pigment and resin formulation from the pipe manufacturer with the CSA stamp confirming the pipe material meets the standard. CSA doesn't do that on the material. And that would be a really difficult thing for a lot of pipe manufacturers to provide. So hopefully with those examples, we kind of clarified um, how easy it is to make a mistake. It is really easy with all the best intentions to make a mistake and specify something that just doesn't exist, or specify something that is confusing. So if you're asking for low-grade cell classification and PE 4710 at the same time, it can get very confusing for people to decide, well, what do they really want here? So to try to move forward here and make it easier for people to prevent making those mistakes, here's our suggestion. Just copy our language. So that was the reason that PPI put together this model specification last year called MS7. As I said at the beginning, this was published in May 2023, and it actually includes the latest current language for how to specify different pipe materials, but specifically HDPE, PERT, PEX, and polypropylene. It has the very specific correct language. If you want to specify any one of those materials, we recommend that the engineers simply just copy and paste language from this. The document is a free download, like all the PPI publications. They're free downloads to our website. You can download it as a PDF file and copy it there. Or if it's easier, if somebody wants a Word version of the file, you can send me a request and I can send you that too if it's easier to copy that way. And you'll see on the right-hand side of this slide, we also have another PPI model specification called MS8, and that's specifically for polypropylene piping systems. So we do publish a series of model specifications. So now we have 8 of them. But MS7 is the one that we're focusing on here. So we're going to take a look at the table of contents. And you can see there's a lot of content in here, but it's organized, we think, in a pretty logical way. So section 1 is all the introductory stuff. It includes reference standards and definitions and warranty requirements. Section 2 is all on the piping products. And there's a section on polyethylene pipe, which is the predominant pipe material. But there's also a section on PERT pipe, which is polyethylene of raised temperature, a section on cross-linked polyethylene pipe as well. And then there's a whole section, chapter 3, on piping installation. And then there's section 4 on indoor piping products. And it's often appropriate to use polypropylene pipe for the indoor piping, like headers or manifolds on the wall. So just giving a quick tour of this, section 1.2 is on definitions, and there's actually 27 different definitions in here, everything from antifreeze to vertical borehole heat exchanger. And these definitions, you'll find very similar definitions in the IAPMO codes and in CSA C448. So we didn't necessarily create new definitions. We're not trying to do that. We just want to make sure that the terminology used in this document is clear with everybody. Section 1.3 is on reference standards. So again, if you're calling out that the pipe must meet ASTM D2774, you see exactly what D2774 refers to. Standard practice for underground installation of thermoplastic pressure piping. That's just one example. And then section 2 is where we get into the exact language for the piping. And like I said, there's 3 different ground loop piping materials listed in here. And specifiers have the option. Again, most people are using HDPE pipe, so you can just go straight to the HDPE pipe section if that's fine. But if you need a higher temperature system or other special properties, you can use PEX pipe or PERT pipe, which there are specific sections in MS7 for those piping materials as well. The main reason to use those other pipe materials, and they're both more expensive than HDPE, is they have higher temperature capabilities. So if you're dealing with a system that has higher than normal temperatures of the fluid going through the pipes, you might want to look at using one of those other piping materials. They also have, especially with PEX, really good stress crack resistance. If you're in very rocky soil, PEX may be the best choice. And also PEX has pretty extraordinary chemical resistance as well. So if you're in an area with contaminated soil and the manufacturer of the polyethylene is not sure if the pipe is going to withstand that contamination for many decades, the PEX may be a preferred material in that case. But most of the time we're talking about polyethylene. So in the section here in polyethylene, which is section 2.2, we have 2.2.1 on HDPE pipe and tubing. And again, it's laid out with reference to the standards. So in letter A, the pipe, according to our language, it has to be certified to the requirements of one of those standards. And then in letter B, we call out that it shall be PE 4710 material. That's the highest grade material that's available for polyethylene pipe today. And letter C, we're saying that the pipe shall be listed by the Plastic Pipe Institute's Hydrostatic Stress Board. So that's a third-party listing, the TR4 listing, to show that the long-term hydrostatic strength data has been validated and approved by that PPI department. We also require that the pipe is certified to the requirements of NSF 358-1. That's the standard that we mentioned earlier that includes the extra testing for chemical compatibility testing. And our specification also requires that the pipe is certified to the requirements of NSF ANSI CAN 61, which is the drinking water health effects standard, to make sure that the pipe is not going to contaminate any drinking water. And although, yes, we're not passing our drinking water through a geothermal pipe, in many cases, our geothermal pipe is passing through our drinking water because it's being installed in the ground through aquifers. So we feel that it's important that whatever pipe you're putting in the ground through our drinking water sources, that pipe can't contaminate the drinking water source. So that's why it's a good idea to have the pipe certified to NSF 61. So a lot of requirements in there. And then there's also a table in there of the minimum pressure requirements and the minimum standard dimension ratio requirements. So this table is fairly easy to use, we think. So for vertical systems, our recommendation is that a minimum SDR of 13.5 shall be used for the vertical systems. It used to be a minimum SDR of 11 in old specifications, and 13.5 pipe is thinner than SDR 11. But we feel that that is suitable now with 4710 material. Running out of time, almost done. Was that the comment? On pipe and tubing.
We're still good, Lance. We have about 8 minutes left.
Okay, good. Thank you, Jeff. There's also very specific language in here for the fittings. So there's 3 different fitting standards listed. So if you're going to use socket type fittings, make sure they're made to ASTM D2683. If it's butt type fusion fittings, make sure they're made to D3261. And if they're electrofusion fittings, make sure they're manufactured to F1055. So those are called out in here. And then the U-bends, it does say that all HDPE U-bend assemblies shall be factory fabricated. And we think that's important as well. You can do proper fusion in the field, obviously, and could make your own U-bends in the field. But we feel that if you just purchase your U-bend assemblies with those U-bends already fused onto the end of the pipe, that's done in a factory in controlled conditions. In this picture here, you can actually see a machine that's built specifically for doing those U-bend fusions in the factory. Nice, clean, and dry every day. Same people every day. You know that you're going to get fittings that are perfect and no chance of a defect at those joints. So having factory fabricated U-bend fittings is important. There's some other details here about the installation of the fittings. Again, referring to the ASTM standard practices to make sure that the fittings in the field are installed correctly. So ASTM F2620 is important. There's also a section on PERT, like I said, and a section on pipe, on PEX pipe, like I said. We won't get into that in detail right now, but all of that content is in there as well. And by the way, back to this table, when I was talking about the minimum SDR for pipes and vertical or horizontal installations, just so everybody is clear what SDR means, it stands for the standard dimension ratio, which is a ratio of the outside diameter to the wall thickness. So the bigger the number, the thicker the wall, the stronger the pipe, and the higher the pressure rating. So an SDR 11 pipe has a thicker wall and therefore a higher pressure rating and more mechanical strength than an SDR 13.5 pipe or an SDR 17 pipe. But we think everybody is clear on that. And then in the specification, there's also even a footnote below the table that clarifies that you really shouldn't be asking for a metric, like a 25 millimeter pipe, because that pipe doesn't meet the standards from ASTM or CSA. There's an installation content in here, but the truth is a lot of this installation content that is in here, you're also going to find in the new edition of C448, which is out for public review right now. So we actually really recommend that people take a look at that in the public review process. And it's going to be a fantastic standard when it comes out. So I'm not going to get into the details of all of this kinds of stuff because actually when the new version of C448 comes out, we're going to be updating the installation section here to make sure it complies with C448 because C448 has actually evolved beyond what we recommended a year ago. So I'm just going to go quickly through these slides and bring us up to the end. Section 4 is on indoor piping products, and you can use polyethylene or PEX for indoor piping, or the polypropylene material, which is the rigid material, also joined via heat fusion. There's a whole section on polypropylene in the model specification as well, if you want to use that for your indoor piping. It's very suitable for geothermal systems, and a lot of manifolds are made of polypropylene. And one other thing too, just kind of a comment to the specifier. We talk about pipe and tubing a lot, and I hope everybody knows that they're not the same. When you get into pipe standards and specification language, pipe dimensions and tubing dimensions are different. So pipe dimensions means IPS sizing or iron pipe sizing or an outside diameter the same as steel pipe of the same name. Whereas when we say tubing, we're referring to nominal tubing sizes, which are the same as copper tube sizing, and all those pipes are smaller. So in this example here, comparing CTS1 tubing versus IPS1 pipe, there's about a 15% difference in the diameters. And so if you don't specify that you want IPS pipe versus CTS tubing, and you think you just want 1-inch pipe, well, if you actually got 1-inch tubing, you'd end up with a product that's smaller than what was expected, and therefore would have less volume inside, less surface area, and higher pressure loss. Both these products exist in the marketplace. So if you're the specifier, you just have to be really clear as to whether or not you're asking for pipe or tubing. And the green note here says MS7 is kind of like a menu. You can specify whatever you like. So we want your feedback on this document. Just one more thing before we wrap up. Most of you are probably aware that at PPI, we have an online plastic pipe calculator, which is free to use. And a couple of years ago, we added all the geothermal pipes into this calculator and all the geothermal fluids into this calculator. So it's really the best tool out there for doing pressure drop calculations for geothermal pipes. Just go to plasticpipecalculator.com. It's a free tool. Select your pipe type and dimensions and sizing. Enter in what your flow rate and your pipe length is. Hit the calculate button, and it'll tell you exactly what your pressure drop is going to be and your velocities and things like that. So that's it. Hopefully that was helpful and useful, and I'm happy to stay for any questions.
Great. Thanks so much, Lance. Very informative and great presentation as always. I'm checking the chat and the Q&A. It looks like Rick has a comment about ICC. You talked about the various standards and codes earlier in the presentation. Rick says ICC accepts PVC for ground loop piping. This is decades old and bad. Do you have any comments on ICC and PVC for ground heat exchangers?
Well, I'm glad you brought that up, Rick. And in fact, at the latest ICC code hearing, which was in Orlando back in April, Greg Kurtz from IXPA submitted code change proposals to remove PVC and CPVC from that code. Because, yeah, we all agree that those pipes are not appropriate for ground loop piping, either the piping in the ground or even in the building. In some cases, they could be used in the building, but there's the potential risk of compatibility issues with antifreeze solutions. So the safest thing is to just not even give people the option for PVC or CPVC piping. So IXPA has actually taken the lead at removing those pipes. So if that goes well, the 2027 version of the IMC will no longer include PVC or CPVC.
Great. Thank you so much, Lance. Jackie has a question here, I think on the calculators, PPI calculators. Could we put a little larger spread on the antifreeze percentage on the pipe calculator? I believe the percentages go in tens and not in 5% increments.
I can take a look at that. Believe it or not, for methanol, one of the hardest things we've ever done is trying to find all the detailed information on methanol mixtures in terms of the viscosities and the densities and things like that. and it was really hard to find some of that data. So what's in the calculator right now, I think that was the best. It was based on the best data that we could find published by various other standards and tables in existence. Um, for sure, for methanol, everything we know is in there. But for the other materials, I'll take a look and see if we could break it down into smaller steps.
Okay, very good. I want to be respectful of your time, Lance, and others. It's half past the hour. Do you still have time for additional questions?
I'm good. Sure.
Okay, very good. So Jared asks, is 2.5-inch pipe and fittings available? You show 2-inch and 3-inch.
Yeah, it is actually. Several of the half sizes are available. Well, they exist in the standards. Whether or not they're on the shelf may be a different question, but 2.5 should be a fairly common pipe size. Once you get into the 3.5 and 4.5, those are probably going to be a special order. So theoretically they exist, but just check with your pipe supplier to make sure they can provide you with the pipes and the fittings for that.
And that would be 4710, the 2.5-inch.
Yeah, pretty much everything today has moved over to 4710, the highest grade polyethylene material that's out there. I think everybody I know of in North America producing geothermal pipe and fittings has all switched over to the 4710 material, which is the strongest material, the best slow crack growth resistance. It's the safest one to use.
Okay. All right. I don't see any other questions here, but I do have one question for you, Lance, if you have a moment.
Sure.
When the designer or engineer uses the specifications, the MS7, they can copy and paste that you mentioned. When they format it into their existing specification for the building and the ground heat exchanger and so forth, do you have any suggestions for how they would put the MS7 into a CSI format so that their numbering system fits their other specifications?
Good question. No, I don't. I'm not. We started looking at the CSI format a couple of years ago when we were developing MS7, and we recognized that that was not our expertise, and we would have actually had to get some outside help to figure out how to reorient it in that way. So we went ahead and published it with our own numbering system. So right now we don't have kind of a mix and match guide to say here's where it goes into section 1303 or whatever.
Okay.
So yeah, I can't help with that at this point.
Okay, well, that might be something where maybe IGSPA and PPI could work together on that type of arrangement.
Absolutely.
Okay.
Yeah, that
Let's
would be
take
great.
one more. Oh, sorry. One more question, and then we'll have to call it good. Christos asks for your opinion on PERC. I'm not familiar with that material.
Yeah, PERC, it's a new designation for a PE pipe with extra crack resistance, and that's what the RC refers to. And I think primarily it's a European designation. The European pipe designation systems are different than what we have in North America. And so in areas where people were using polyethylene pipe in really rocky soils, they wanted to have the highest level of slow crack growth resistance to the pipe so that if it was going to be rubbing against a rock, you want to make sure that that little scratch is not going to propagate over time. So the Europeans developed a PERC formula to give extra crack growth resistance. And they do that at the molecular level by having a mix of long and short molecules all being mixed tightly with each other. The PE 4710 that we have in North America today, it's for all intents and purposes equivalent to PERC. And even with the PE 4710 today, the minimum requirement, according to the standardized test, it's called a PENT test. It's 500-hour requirement in this test. Much of the PE 4710 you can buy today is even 3 or 4 times better than the minimum requirement, and better than the PERC material. So I could get deep into the weeds here, which we shouldn't do that right now, but feel free to follow up with me for any more details on that.
Very good. I learned something every time, Lance. I certainly appreciate it. Thank you for your time. Thanks to Centennial Plastics for sponsoring this webinar. Any closing thoughts, Lance?
I'm glad everybody showed up on a Friday morning right before a holiday week. And no, I don't think my email address was shown, but you probably can find it on the announcement that was put out for this webinar. But if you can't find it, it's just L and my last name, MacNevin, at plasticpipe.org. If you have trouble finding the document on our website, or if you'd like to get the Word version to make it easier to copy and paste the language, and give us feedback as well. Like I said, this was the first edition ever of our model specification for geothermal piping. If there's something in here that we missed, let us know, and we have a process that allows us to update documents as needed.
Great. All right. Thanks everyone for joining us. Have a nice weekend. See ya.
Thanks, Jeff.